Dr. Oksana Sytar. She's an international expert in pharmacology and toxicology, plant and soil sciences, and environmental sciences. Phytoremediation, cornerstone of Oksana's previous research, emerged as a renewed focus in 2022 due to Ukraine conflict. Study of plant-hyperaccumulators, pivotal in this research, progressed thanks to internship and esteemed institutions such as University of Hyderabad in India, University of Lorient in France, and backed by research fellowship from the hosting countries. In this presentation, the monitoring of heavy metal pollution in Ukraine is based on literature review of Ukrainian national reports and from three main academic resources such as Web of Science, Scopus, and Google Scholar. It is important to emphasize that the full-scale Russian invasion to Ukraine in 2022 may increase heavy metal pollution in areas which has been already polluted with these heavy metals. And presented data and the analysis reveals that ongoing military conflict influence may lead to increase of heavy metal content in air, water, and soil. And it is recommended to use in highly contaminated area contemporary technologies of phytoremediation along with crop rotation using plant-hyperaccumulators of heavy metals. So now I'm passing to Oksana, who will give the context of this announcement.
Yes, I will try just simple way. Can I see my presentation on the screen?
Yes, and yeah, I forgot to mention that at the top of the screen, you have an option to switch between the shared screens.
Yes, this is, I know it's top of the screen.
Actually, now I only see one screen of Irina. Irina, are you sharing both?
I need your technical support because I can't share my second screen right now.
Okay, now I enabled this feature, so now you should be available to do it.
Yes, then just one moment.
Yeah, so now I see that Irina is sharing both screen, and then at the top panel under view option, you see shared screens, and then you can switch between shared screens.
I will try shared screens one I see, and on Ukrainian I see, but on English no. Now thanks, Irina. So I will kindly ask your assistance. So I will later. So now I would like to introduce. I think introduction of myself was done very nicely. So this work will be like analytical data presented. So we will start from next slide for a moment. Irina, please next slide. Recent years, normally the three oilseed crops like sunflower, rapeseeds, and soybeans occupied on average about 22 of the structure of sown areas in Ukraine, which is beyond the scientifically sustainable limits of saturation of crop rotation with these crops. Primary feedstock production of Ukraine of biodiesel in Ukraine mostly used Brassica species and Helianthus species, and these species also acknowledged for their phytoremediation potential to polish contaminated soils. The harvested produce is ideal for bioenergy as well. Please next slide. The Ministry of in these slides, I will try to present data which was done about analyzed from statistical analysis of Ministry of Natural Protection in Ukraine. It was from 2015 till some literature analysis to 2022 about possible situation of heavy metal pollution in Ukraine. On this map, we see a situation with lead pollution. So lead levels, for example, in Kyiv region, at that period were at 4.5 times over the limit. Especially, it's important to admit cars in Kyiv as a major source of lead due to gas combustion and along with smelting and mining. In as we see, some regions like Zhytomyr, Chernihiv, and Sumy, they are the most polluted with lead. Average level of lead is presented in the south of Ukraine and little bit on west part of Ukraine, where is more industrial areas. A study from 2020 of Czech and Ukrainian ecologists found more heavy metals in the river and soils in Pavlograd in Dnipropetrovsk region. Another study were concentrated in Kryvyi Rih district soils to show high levels and flows of iron and lead. So it was in quantity 60 and 99%. I would like to admit that real and serious information about presence of heavy metals in the Ukrainian soils is not available because it was not presented full screening and full information. So I tried to collect information which was in scientific literature and some statistical data. Please, next slide. I would like in previous slides that lead and cadmium, this is one of the most dangerous and heavy metals which can destroy soil. And second, which is highly present in Ukraine, this is nickel. So it's known that nickel is known as main anthropogenic source of nickel emission is fossil fuels and traffic as well. Also industry. So the highest nickel content in the soils was found again in Zhytomyr, Kyiv, Zaporizhia, Donetsk, Kharkiv, Luhansk, and it's interesting that it also high level of Chernivtsi. It's maybe connected with some also industrial sectors presented in these regions. Especially in agricultural land, also in Vinnytsia region, it was studied from 2021, shows also high level of nickel, and but it's still possible these lands to use for eco-friendly farming. Areas of so it's important to admit that average nickel pollution it's in Chernihiv, Sumy, Zaporizhia, Ivano-Frankivsk, Rivne, and also Transcarpathian regions. Please, next slide. A similar situation has been observed with pollution of soil with zinc and copper. Again, central regions and north central regions, Zhytomyr, Kyiv, and Chernihiv, where are the most polluted with these heavy metals. And for example, in gray forest soils of Vinnytsia region, the levels of zinc and copper were 32.5 milligrams and 12 milligrams per kilogram respectively. It's also on the average level. In the Kherson region was determined next levels of trace elements. Zinc in the soil of the region was estimated at low level, and cobalt also at low level. So I think next slide I will present about crop production in these regions, and also this crop production is connected with productions on main crop, which is connected with bioenergy and biodiesel production. As we see on this slide, how it was production, rapeseed oil production, soybean oil, and sunflower seed oil seed production in Ukraine by years. Even military conflict, I would say that rapeseed production and soybean oil production did not decrease significantly as we compare to 2010. In 2022, we have numbers mostly equal with 2020, 2021. So it still says about potential of Ukrainian agricultural production, agricultural sector, even in a situation of conflict. Please, next slide. So in 2002, when it started military conflict, I started to do analysis how it's possible to use or potential of these regions which could be contaminated with which was already were contaminated with heavy metals, and I tried to make analysis with high level of heavy metals present, which is heavy metals danger for regions, and which is in average quantity, and about possible area under conflict influence, and about the potential of harvest of crops which are important for these regions. For example, for wheat productions, with regions with high wheat productions, we see it's Kyiv, Chernihiv, which with high level of contamination, lead, nickel, and copper. Zhytomyr region is also with high level of nickel, lead, copper as well. Sumy and Kharkiv regions with yield harvesting of wheat on 1st December 2021 were 48.2, 48.6 kilogram per hectare. That is also enough high production, but there are high level of lead, chrome, and nickel respectively. For the regions of highest corn production, this is down table. See that the same Chernihiv, Kyiv, Zhytomyr, and plus Kherson regions, which is now the biggest area occupied. So these regions are characterized with high level of lead, nickel, cuprum, especially. Just Kherson region on that time was this average level of lead, and it's not high, and it's I would say that Kherson region really was good for eco farming. So the regions with higher, please next slide. Barley. The regions of highest barley production were again Chernihiv, Kyiv, Zhytomyr, Kherson, and Odessa, with harvesting yield in the range 40-42 kilogram per hectare. These regions are characterized with high level of lead, nickel, cuprum. Just Odessa and Kherson regions on that time has average level of lead, not high, and again these regions were very perspective for eco farming. I think important also admit Dnipropetrovsk region with not that high barley production, but not significant heavy metal pollution on 2021. And I think for the moment situation is completely changed because missiles attack and other it will impact heavy metal in the air and also in the soil. So I would add plus 15-20% increase of heavy metals in these regions, and so also please next rapeseed, please back. Rapeseed production. The regions of highest rapeseed production again were Chernihiv, Kyiv, Sumy. As I would like to admit that this region also characterized with high level of cuprum and lead. This is Chernihiv, lead, nickel, cuprum in Kyiv, and Sumy. This is high level of lead. Sunflower seed production was also very high in Kyiv region, and also this north region, which is connected with Chernihiv, again Kyiv, Kharkiv on the average level, and Sumy. So similar situation for all corn productions. Please next slide now. So as I would like to admit for heavy metal effects and their effects on crop production on last scientific findings, the increased level of lead, nickel, chrome may show detrimental effect towards plant growth and yield. It's 100%, so crop yields should be decreased. For example, lead, cadmium, chrome, and cobalt during a study were observed to be responsible to the poor growth of corn plants. So corn plants, which I said before, can be perspective. At extreme levels, toxic metals could result in oxidative stress in plants, mutilation of cell structure, and again occur different oxidative stress reaction in plant cells, which also can decrease growth and development of plants, and also decrease quality of products. determinated effects also special on morphology, growth, and photosynthetic processes of corn and wheat. Of course, lead mostly concentrated in the roots, but also its affect crop production of and also development of vegetative and vegetative part and the seed germination. Cadmium in the wheat declines seed germination and support reduction in nutrient content of plant. Chromium is stunted shoot and root growth of wheat. Nickel support reduction and also changing of wheat plant nutrition process, so completely stop it. For all these things, it's important if we would like to grow some wheat is known popular crop in Ukraine. So for this, it's important to use crop rotation. I would recommend to use crop rotation with plants which can be possible hyperaccumulators of heavy metals. It's also possible to use some combination with specific microorganism preparates for this soil for their phytoremediation. Please, next slide. And from these plants, who have phytoremediating potential, plants which are possible later to use for applied transmission. This is vegetables who have vegetables oil potential, like bioenergetic crops plants. And it's known that in these vegetable oil plants, for example, in produced by plants, it's energetically rich and abundant forms of reduced carbon available from nature. So these oils are mostly derived from plants from triacyl glycerols stored in the seeds. So during seed development, its photosynthesis from the mother plant is imported in the form of sugars, and the seed converts in precursors in fatty acid biosynthesis. As we see here is the tables up presented characteristic and presence of oils in rapeseed, sunflowers, and soybeans, and they have average different biodiversity and different bioenergetic potential. And especially from this bioenergetic potential, going to choose this source from combination of these oils and acids presented. So they are choosing like source of biodiesel. And this is source of biodiesel usually depends on the crops and from also regional climate. And for example, in the South and North America, soybean oils is the most commonly biodiesel feedstock, whereas rapeseed oil is the most regular source in the European Union, whereas share of the total area of oilseed crops in somewhere more than 80%. As previously we spoke, that rapeseed is also popular crop in Ukraine, also enough high big areas for harvesting. Biodiesel is monoalkyl esters of long-chain fatty acids derived from renewable feedstocks. So it's okay. The parameters which define the quality of biodiesel can be divided into two groups. One group contains general parameters, which are also used by mineral or oil-based fuel, and the other group especially describes the chemical composition and purity of fatty acid alkyl esters. And second group contains the general and third group, the vegetable oil specific parameters and the corresponding value of fatty acid methyl esters according to standards of above countries. The table 3 and down shows standards of each country which use in biodiesel and present of mono glycerid, diacyl glycerid, triacyl glycerid, glycerols, for example, typical for standards Austria, Czech Republic, France, Germany, Italy, USA, and Brazil. Please, next slide. So normally it's proposed as a plant sunflower, for example, this is plant which is possible have potential to hyperaccumulate lead. So sunflower can be used seed for like feed and fuel. Also can be made like protein cakes for animal feeds, and also for biodiesel production, like sunflower oils can be used for biodiesel, and also for later for electricity generation and some other needs. Please, next slide. So together, as I admitted before, sunflower is one big potential which is discussed and one of perspective in Ukraine. So it's used for copper phytoextraction and oil seal production. This is energetic yield of soil is of sunflower is very high. Also, it can remove lead and cadmium in roots, mostly it goes accumulation. So in this case, it can be also used vegetative part of sunflower plants. For example, soybean can be used as hyperaccumulator lead, cadmium, cuprum, and zinc. And peanut also very good for zinc accumulation. So depending from kind of plants, it's possible to use this plant for crop rotation of some specific region. In crop rotation of region, if we want to little bit decrease heavy level of heavy metals in the soils. And for example, and later to use some part of this plant, like vegetative part of plant, for biodiesel production. So it's always, it can be chain from first step to like phytoremediation, and also for some business, it also can be economical value can be used. Next slide, please. And a special interest in Ukraine last years was and not just in Ukraine, it's search another kind of plants, not just sunflower, not just rapeseeds, not which is already installed high crop production in Ukraine, but also other plants with heavy metal accumulating effect. This is Brassica juncea. Also Brassica species very is known for high accumulation of lead. Again, lead, which I spoke before, the one of the dangerous heavy metal in Ukraine for moment. Lead, cadmium, nickel. Also, Brassica juncea, Jatropha curcas, miscanthus species. Miscanthus also very good for as a bioenergetic crop. And it's also shown the highest yield protein of oil content and biodiesel yield production. It's already going high crop production of this miscanthus in Austria, Saskatchewan, Canada, southern Ethiopia, and northern Poland. And I would like to admit the climate condition for cultivation of Camellia sativa is in Ukraine may be similar to Poland region, and it was shown in publication Bloom et al. And this last findings about Camellia sativa for phytoremediation is presented from data from 2022 to 2023. So as it's also very good for clean up from copper and zinc. This plant can be recommended for clean up soil from zinc and copper. So as like main conclusion, we see how a situation with heavy metals contamination in Ukraine, which region needs the most, how to say, to have a proposal to be cleaned the most for more eco-farming production. And it's possible to say which plants we can recommend for crop rotation for clean up this soil, and to have also profit from these lands during period of crop rotation. So for example, if it was wheat, and we can later grow rape or sunflower or Camellia sativa and use it for for biofuel and production or like bioenergetic crop. So it can bring some potential and for clean up soils. But for this, we need to attract someone who is interested in biodiesel production and development biodiesel production in Ukraine. Next slide. Thank you for the attention.
Thank you very much, Oksana, for this very interesting presentation. I just remind to participants that you are supposed to ask your questions to presenter in a spreadsheet. I send the link in a chat in both Zoom and YouTube. So far I see no question in a spreadsheet, so you can also unmute yourself and ask question. I ask you not to raise hand, not to wave hands, because I don't see it. Just unmute and ask your questions. And while I see no questions, maybe I will ask my own question. I'm sorry if I missed this information, but in which parts usually plants accumulate these heavy metals? And if our task is to remove this heavy metal from the soil and not to spread them in other parts of environments. For example, imagine if it's biodiesel and we burn it and it's just spread
Yes, this is
elsewhere. Yeah.
discussion.
Yeah, so how is it, where it is accumulated, and what should be the management to really remove with this hyperaccumulator chromes, to really remove heavy metals from soils and not to allow contamination of other environments?
Yes, question is still under discussion, because this is technologies. First of all, heavy metals mostly accumulated in the roots and a little bit in the stem, but normally they are not found in the leaves and bigger part, in less quantity, but the highest accumulation in the roots. It depends from kind of plants also, I would like to admit. For example, this is for sunflower. For other plants, it can be in stems and a little bit in leaves, but this quantity in the leaves will be not that dangerous. But accumulation will be enough for clean up soil. It's my point. But it's still discussion about technology, how to clean up, and for these biodiesel technologies to make it clean and to separation. And this is still under discussion. It's not
interesting.
it's not
I'm not an expert, but I did a small literature review, and I saw that at least not in case of biodiesel, but in case of combustion, if you burn this, there is an established technology to recover some metals from the ash.
So this is ash. Yes, this is if this technology can be used for this, it's perfect. So we will be able to do it. So it's important to find chain of all these production and produce companies who do all these steps. For example, we have in Ukraine agrarians who can grow. We can recommend them crop rotation and use these kind of plants for crop rotation for clean up soils. But after these important points, we don't have in Ukraine companies. We should have a screening of information who are doing biodiesel. I have this information that we have some laws in Ukraine which make no taxes for companies who like to support development. These companies, no taxes for these companies, but about their quantities and their concentration in Ukraine, it's question. If we would know this information, plus we can it's possible to make this all chain, agricultural people who do productions, our recommendation with all these cultivations and changing and bioenergy companies and these technologies which can be used. So this will be perfect chain of participants for clean up soils in Ukraine. Also, people who do microbiology, also some microbiological technologies also can help with some bacteria clean up soils. So it's in complex, it's possible to do.
Thank you. Are there any questions from other participants? You can unmute yourself and just ask your question. Okay, while I see no other questions, so I would like to ask my second question. It is linked actually with the next section for today, which is about nature conservation and wildlife protection. Are there any studies on crops which accumulate high quantities of heavy metals in their nectar and pollen, so that it could pose the risk to pollinators.
It's a question for me.
Yeah, I mean that because you did this literature review, maybe you found that like some crops like accumulate like very high quantities in nectar and pollen. And my idea is that if such crop exists, our recommendation would be to avoid cultivating these crops at least until the quantities of these contaminants would reduce significantly in soils.
I think this information. I think this kind of crops not present information in Europe about this kind of plants which really accumulate high level of heavy metals. Maybe some plants can be what about hyperaccumulators? It can be some plants who are accumulating high level, but they are still in the discussion of study. Some plants can be identificator of presence of heavy metals, but the highest number, I don't have this information. So some have really like point with like lighting of some heavy metal. No.
Okay. Yes, but I mean that at least if you did not find this information with your review, it means that at least it's not much of these plants, at least not among the main crops, which is already good.
No, not in the main crop. Yes.
Perfect. Any questions from other participants?
Can I ask one question?
Yes.
My question is, I'm interested in, are you involved in your program intention to estimate the role of Kaspari belt in the root of cereal crops, for instance, regarding to heavy metal, mostly I see lead, cadmium, because in my case, sometimes when I managed some field experiment with artificial supplementation heavy metal, in case of one maximum permission concentration with black soil, really I was surprised to see interesting effect then in case of black soil buffer capacity, heavy metal not depress the growths of crop, but any other way for me, because I cannot say that I really was trying to estimate Kaspari belt. I knew only from, for instance, Ilyin book about it. Maybe you know, that is why it's my question.
I think this reaction, it can be, do you know about hormosis?
No.
This is hormosis reaction. It's about how is plant can adapt for some level and concentration of heavy metal. So some plant can have like adaptation. It's hormosis reaction. They not really influenced by heavy metal. So it's going adaptation. So hormosis line, it's like we see firstly decrease and after we see increase and or some stabilization. So this is the reaction of hormosis. And normally for such big field experiments and with concentration or so much, it should be replication, maybe biological replication, minimum 2-3 years to know for sure that it's going something like some danger effect. For example, heavy metals, but we can have some also other factors which can affect climate, temperature, plus other water. When it's going raining, so it can be a little bit another situation. All in complexity, it have another effect. But heavy metal in the soil, depending. And did you manage analysis of soil, heavy metals in the soil and in plant in your experiment?
Yeah, really, in soil and plant.
And how it was concentration?
I told you that I have managed in mentioned experiment for instance, for 6 famous heavy metal, one maximum permission concentration. Sometimes I made other one 5. It was in the start of my even 10 maximum permission concentration. 10 really killed, but in case of
average can make hormesis. This is hormesis reaction. It's like going at the plant adaptation, but it can be hormesis. But after, it's important to see quality of plant. Result, seed. What contains seed? If seed contain heavy metals or not? This is the most important point, because now the biggest question for Ukraine about, for example, this stopped grain export. This is the main question about quality of grains. And if a scientist explain clever way what is going on with heavy metals and also with accumulation of lead, not just lead, heavy metals, and if it's not affect seed production or quality results, so it can be these grains can be used, for example. But if your experiment was with this plant and you think that it's not this plant hyperaccumulator or not, what do you think?
In my case, because I was working with cereal crops like barley, for instance, soybean was also included in experiment. Really, it was, there were differences. You understand, because soybean is a leguminous sample crop. That is why it was differences. My question regarding Kaspari Bell connected also with famous information about miscanthus ability to keep heavy metal in the rhizomes. It's very interesting from one point of view, but to think about technology use this effect, still now I have information, but still now I do not think that it is enough so that makes some conclusion.
This is, I agree with you. It should be more. It should be more studied. No, it's not. It's just the last years. What is people are looking for? I just wanted to admit about plants which are on last years looking for like potential hyperaccumulators. For example, in one meeting, it was like business conference, and also how science possible to use for business. I went from one point to another, from one block to another, to ask if someone want to use plants for phytoremediation or for soils or water. No one was interesting. One just people propose mostly easy ways, because to use crop rotation and all these plants is more complicated. All calculate profit. But I think for if we will propose, for example, some like crops which it can be used for bioenergetic needs, and again, as I said, we will use all these chains, it can have some potential, because other companies, for example, who is more technologies, so they propose some machines who will clean some parts water, or some microbiologists also propose to clean water in some places, but it's not a long-term effect. For long-term effect, we need to use more longer this. I think it's still all this, like my idea, like I told, we need to use standard crop, which can be potential for, and for also for investors and for profit. No one will grow big areas, clean up grid areas without profit.
Sure.
It's my opinion. We need just to find this whole chain and to say how it's possible to work with it and how to clean, because without financial support, who from agrarian will want to lose their finances, and when they do growth of crops, some crop of plants on big hectares. We see how it's problematic in Ukraine now with this contamination and other things. But thank you for your experience. It's very it's visible that you are very good in what you are doing.
I will keep and to think about hormesis effect.
Please check hormesis effect. It's really what is going on.
Thank you so much. Thank you.